Hello students, welcome back to Physics with SAFDAR. Now you are watching IGCSE Physics Past Paper Solution series. In this classified series, we are going to solve past paper question topic wise. So let's start the questions. This is paper 2020 specimen. The question number 1 is, a car has a mass of 1000 kg and momentum of 12,000 kg per second. What is its kinetic energy? Because you need kinetic energy in step 1, first you need to write its equation. Kinetic energy, you know well, is equal to half times mass times velocity squared. If you want to calculate the kinetic energy, then you need the two things, mass of the car and its velocity. Look at the question again. What we have? We have mass, that is 1000 kg, and momentum, but we don't have velocity. So first we write the momentum. It gives the value of velocity. The momentum is equals to mass times velocity. Momentum is given 12,000. Mass of the car is 1000. Then you can find the velocity of the car easily. 12,000 over 1000, it gives velocity. After simplification, we get 12 with unit meter per second. Now by using equation number 1, you can find the kinetic energy of the car. So write the equation number 1, that is half times mass, that is 1000, V12, make it squared. After the simplification, what we get? We get 72,000 joules. But look at the options. In the option, the answers are given in the kilojoules. So you need to change your energy joules to kilojoules. It gives 72 kilojoules. Now check with the options. Option number C. So that is the final answer. Question number 2. The sun is the original source of energy for many of our energy resources. Which energy resource does not originate from the sun? Look at this sentence. Energy resource does not originate from the sun. After reading this line, you can select easily geothermal as the correct option, because if you look at the others, hydroelectric, waves and wind are caused by the sun. This question from February-March 2019 series. Now the question is, a car of mass 1500 kg has a speed of 20 meter per second. It accelerates until its speed is 25 meter per second. What is the increase in the kinetic energy of the car? Underline the numbers. We have mass of the car, initial speed of the car, and final speed of the car. You need to calculate the increase in kinetic energy, that is equals to half m squared of the final velocity minus half m squared of the initial velocity. By taking common half m from the right hand side, we get half times m in the bracket, Vf squared and Vi square are left. Now you can substitute the numbers. Half The mass of the car is 1500. Final velocity, that is 25. Make it squared, minus initial velocity is 20 squared. After the simplification, we get 168750. Because we measured energy, you can write joule. Look at the option. In the options, we have answer in kilojoules. Then you need to change your energy from joules to kilojoules. 168750 with 1000, then we get around 168.75 kilojoules. Round off this number, then we get 170 kilojoule, and that is the correct option. Question number 4. The question is, which source of energy uses the production of steam to generate electricity? So, steam to electricity. Now look at the options one by one. The first of all is hydroelectric. You know well, water flowing down from the lake turns the generator, so there is no use of steam in this process. Look at the option B, nuclear. You know well, in the nuclear reactors, nuclear reaction takes place. Because of that, a big amount of heat is produced, and that heat is used to boil water, convert into steam, and steam turns the turbine and electricity generated. So this is very close to the right option, but check the others. Tides. Tides are very similar, like generation of electricity by hydroelectric method. There is no formation of steam. Waves, the same like hydroelectric, no steam generation in this process. If you follow all the things, so you can write option B is the correct one. This question is taken October-November 2018 series. The question is, which device is designed to convert chemical energy into kinetic energy? In the options, you have 4 devices. In the question, you need to check conversion of chemical into kinetic energy. Check one by one. AC generators. We know well, AC generator convert mechanical energy into electrical energy. Torch. A battery powered torch convert chemical energy into light energy. Car engine. Fuel that contains the chemical energy. Okay. Chemical energy and the motion of the car, that is kinetic energy. And the last one is wind up mechanical clock. In the wind, moving air, that means there is a change of kinetic energy to mechanical energy. If look at the option, what we need chemical to kinetic energy, and that is option number C is the right answer. The question number 6. This question is taken from the same series October-November 2018. The question is, an object initially at rest is dropped from a height of 12.0 meter. The change in gravitational potential energy when it falls to the ground is 565 joules. The frictional forces are negligible. What is its speed when it hits the ground? It's a ball, and this is the ground level. Initially it was at rest, mean its initial velocity is 0, and the height is given from this point to the ground is 12.0 meter. Now, you know well, when object moves down, it loses potential energy and gains kinetic energy. When it hit the ground, it loses all its potential energy, and that is converted into kinetic energy completely. Why? Because it is given the frictional forces are negligible. If the frictional forces are negligible, it means you can write the loss of potential energy is equals to gain in kinetic energy. Gain in kinetic energy. So loss of potential, you know well, mgh is equals to half mv squared. Now you can make some simplification. You can cancel m with m, then gh is equals to half time v squared. And you look at the question, what we need the speed when the object hits the ground. So make v as a subject, so you can write twice of gh is equals to v squared, and finally 2 times gh root is equals to v. Now you can substitute all the numbers. 2 times g, you know well, it is 10 on surface of earth, and h is given 12.0, and take square root, then we get 15.49, and that is equals to 15.5 with unit meter per second. So look at the options. Option number B is the correct answer. Now this question number 7 is taken from October-November 2017 series. The diagram shows the path of a stone that is thrown from X and reach its maximum height. The stone gains 10 joule of potential energy as it's moved from X to Y. The stone has 2.0 joules of kinetic energy at Y. Air resistance can be ignored. How much kinetic energy did the stone have immediately after it was thrown at X? Look at this diagram. The point X is the initial position of the stone. You know well, in the beginning, because it did not get any height, so here the potential energy is 0, and when you throw, it has some kinetic energy. Suppose that is k1. We don't know its number. When the stone moves and reach at Y, now it has some height. That's why it gains some potential energy, and it is given the gain of potential energy at point Y is equals to 10 joules. But at the same point it has some kinetic energy as well, and that is 2.0. So you can write that is kinetic energy K2 is equals to 2.0 joule. So for this situation we can write gain in potential energy is equals to loss of kinetic energy. Here the gain of potential energy is 10 joules. K1 and finally K2. Now substitute the numbers. K was the initial kinetic energy. We don't know this number, but the K2 it's given 2.0. Now rearrange the equation. 10 plus 2 is equals to K1, and K1 is the initial kinetic energy of the stone. So finally we get K1 is equals to 12 joules. This question from October-November 2016 series. A car of mass 800 kilograms travels over a hill of height h. By traveling to the top of the hill, the car gains 40,000 joules of gravitational potential energy. The gravitational field strength is 10 Newton per kilogram. What is the height h of the hill? That's the question we have. Now look at the diagram. The car has mass 800 kilogram. In the beginning, the car on the road, no vertical height, no gravitational potential energy. When the car reached at this height, it gains gravitational potential energy, and that is given 40,000. And you need to calculate this height. So write the equation of gravitational potential energy. Gravitational potential energy you can write like this: m times g times h. And we need h, so make h as a subject. Then we get 40,000 over 800 times 10. After the simplification, we get h is equals to 5 meter. Look at the option. Option number A is 5.0 meter, and that is the correct answer. This question from October-November 2015 series, question number 9. The question is: electrical energy may be obtained from nuclear fission. In which order is the energy transferred in this process? A nuclear reaction takes place in a nuclear reactor. As a result of this nuclear reactor, a big amount of heat is produced that is used in boiler. Then boiler produces steam, and steam is used to turn the turbines. And finally, turbine rotate generators, and we get electricity. So look at the option. In option A, nuclear fuel, it's okay. Second step, the generator, that is not correct. Option B, starting with the nuclear fuel, it's okay. In the second step, generator, that is not correct. Nuclear fuel in option C, reactor and boiler, it's okay. But look at the third step, generator, that is not correct. The last option D is starting with the nuclear fuel, it's okay. Then reactor and boiler, correct. Then turbine, and finally generator. So that is the correct sequence. Option D is the final answer. Once again, thank you very much for watching this video. I suggest you follow the playlist of the channel. In that you can find all the lessons you need for your IGCSE physics. So keep watching Physics with SAFDAR for better results in exam. See you in the next lesson.